Hello everybody, welcome back. So today we're going to talk about hyperbola, another conic section, and here we go. First definition, locus definition of hyperbola. For every point on the curve, the absolute value of the difference from two fixed points, they call them foci, is a positive constant. Well, what the heck does that mean? Well, here is the graph that I have, but ignore the red lines, red curves. But imagine that you have two fixed points, and I call them F1 and F2. Then they call them foci, each one focus. And let's suppose we have a point P on the graph, coordinate XY. Now, if this point moves in a path according to the guideline that the distance between this point P and F1, let's call that B, and let's call the distance between point P and F2, let's call that A. Now, if this point moves in such a way that when you take the absolute value of the difference of A, the distance A and distance B, and that value becomes constant, you will get these two curvatures that we call hyperbola. Okay, and if you remember conic sections is that when the plane crosses the cones, the inverted cones, two of them at the right angle, as long as the plane doesn't cross the center of the double napped cone. Okay, so that's the definition. Now let's go ahead and write up a couple of things. General form of a hyperbola is given by this form, ax squared minus by squared plus cx plus dy plus e equal to 0. Yeah, I know, it's ugly, but that's what the general form is. But the standard form is just like circles and ellipse and parabolas. They have a center, and there is a and b that actually define some of the characteristics of hyperbola, and that has to be equal to 1. Okay, let's go and define what these are. First, the center is h and k. Then there is a transverse axis, and that is always the length of transverse axis is 2 times the square root of a squared, or we can say 2a. Now in this case, based on this standard form that I have written here, a is a transverse axis because it is related to x, and it's a horizontal transverse axis, okay? And that means that the actual graph, the line, the two curvatures, they are set up horizontally like this graph that is showing here. So horizontal, okay? If this was not positive, so the value of x in here, there's no in front, there's no negative in front, that's positive. That's why you get the horizontal transverse axis. If it was the other way around and this was negative, the x was negative in front here and y in here was positive, then your transverse axis would have been vertical. That means your graph would have been, there's one up top of the y values of y-axis, and then there would be another curvature at the bottom of the y-axis. All right, so in this case, this is what's called transverse axis, and that's the length of that is 2a, and that's from the center, always from the center. Okay, and then the next one is called the conjugate axis, and that is 2 times the square root of b squared, which is 2b. Okay, and there is a relationship between, remember the focus or foci, they call them F1 and F2. The distance, and you can actually get the value of F1 and F2. They are based on the distance of F1 is equal to the square root of a squared plus b squared. Okay, and that is the transverse axis and conjugate axis, and that's where you can find where the coordinate of the foci are on both sides the graph. And the vertices, this is called, so this point right here and this point right there are vertices of the hyperbola. Okay, and then there is another piece of information we need, and that is every hyperbola has asymptotes, and they specifically have two asymptotes. Okay, and the equation of asymptotes are given as such. First, both asymptotes, they're going to cross each other, and they cross at the center of hyperbola. So that's the first characteristics you must know. All right, so both of these asymptotes, but remember, there are invisible lines or boundary lines that the curve do not cross, but both of these graphs become asymptotic, and they follow the same typical discontinuous graph. So they pass through the center, so that's the center of the hyperbola, and they cross each other. And then the equation of that is given based on h and k, which is the center, and the values of the transverse and conjugate axes. Okay, the length of them actually is the half of the length of the transverse axis, and so is the conjugate axis. And there is this b over a. First of all, there's a plus or minus because of there's a one positive slope, there's one negative slope, and the slope of these two lines is b over a. It's just rise over run. That's what it is. And rise over run is the value that is under y. Y is the vertical, and a is under x, which is the horizontal. So that's straightforward. You can just read it off. Now, regardless of what type of hyperbola you have, horizontal hyperbola or vertical hyperbola. So what you see as an example, this is a horizontal hyperbola. Okay, the vertical hyperbola will look like this. This would be the vertical hyperbola, and it doesn't really matter as long as you realize, by the way, the equation of this one will end up being but realize that who cares what this A or B is? Whatever the numbers are, they belong to the vertical, so that A is under Y, B is under X. So in this case, the slope is rise, which is A over B, plus or minus. Okay, be aware that whatever is under the Y, that's your vertical, and whatever is under the x, that's your horizontal, and then depending on if it's a transverse axis or a conjugate axis, look at it as a horizontal hyperbola or a vertical hyperbola. Okay, now if you have a hyperbola where a and b, so the values under x and value under y, they're the same, then this hyperbola will be called a rectangular hyperbola. Okay, so it's actually square. It looks like square. That's what it is, the inside. And what happened is that the two asymptotes, they actually cross each other at 90 degrees, and you can see that the slope of this asymptote, the slope will end up being 1, right? And that's why you will get you can get an equation without any issues in here, and the equation of this one will be y equals to plus or minus x. Okay, that's what it will be, because they're the same. Okay, so that's the equation of the two equations for the asymptotes. All right, now let's do a couple of examples and then go through that. So let's start the easy one. We have this hyperbola. Now we're going to write up all the information that we need. Notice that h and k are 0. So center 0, 0. Now the length of the transverse axis is equal to 6 because 9 is 3 squared. So remember, this coming from here, that was 3 squared, but you just want to take 3 and then times it by 2. And then the length of the conjugate axis, and I do have to say that this is horizontal, and then the conjugate axis is vertical, and that is 4 because it's a square root of 4, then times it by 2, that would be it. Okay, so we have those two. The slope of asymptotes and then the equation of them is rise over run. So the slope m is equal to 2 over 3, and it is plus or minus 2/3, and then the equation of the both asymptotes, equation of the lines, is if you remember, y is equal to plus or minus 2/3, and then this is x minus 0 plus k or minus k, which is 0. So that would be y equals to plus or minus 2/3 x. So we got the two equations of the asymptotes. All right, now um, the vertices, we need to find out what that is, but we can do that on a graph. So let's do graph now. All right, so center is 0, 0. That's easy. So right there, so that's 0, 0. Then we're going to go through the transverse axis. So we're going to go 9 is the value that we're going to use. So square root of 9 is equal to 3. So from 0, we're going to go 1, 2, 3. So that would be 1 vertex, and then we go to the left, that's another vertex, so that's 3 and negative 3. Fantastic. Now the conjugate, you go up from that, so 1, 2, so that creates a boundary line that you can actually create this box where you can actually draw and then guide your graph without technology. This is freestyle graph now, right? Remember, you have two asymptotes that you have to draw. Well, the two asymptotes, they're going to cross the center of the hyperbola. That's number one. Number two, once you draw this box, this imaginary box, based on the conjugate, okay, so the conjugate is square root of 2, this is transverse axis, and then square root of 4 is equal to 2, and that is the conjugate axis. All right, so once you have that, now you can go ahead and actually draw, and the beauty of it is that it's corner to corner. So you got the point here at the end, each of the corners of this rectangle that you see, and then you got a point in the middle. So you got 3 points. You can draw a straight line right through it using a ruler, and you do the same thing to the other side, okay, and that becomes your asymptote. So I'm going to do that freestyle with the red. So here it is, okay? One is positive slope, the other one is negative slope. The equations we got, which is right here, these are the two equations for the slopes. One is the 2/3 x is that one, okay? The other one is negative, which is negative 2/3 x, and that's y2. Let's call that y1 for the two equations for asymptotes. Okay, now that we have that, we have the vertices, and now we're just going to graph, and this is the freestyle graph. Although if you want to make it very accurate, you need to choose at least 2 points in each region on top of the vertices, and that would be the best thing to do. But you can do that with using a table of values, but in general you just go ahead and graph it, but you use asymptotes as a guide. So, and here it is, and I use the asymptotes as my guide. So I come in close, and then I make sure that the curve is asymptotic on both sides, and so is the other side. And here it is. That's the graph of this hyperbola. Okay, let's do another one. So look at this one. This is a hyperbola. There's a negative between the two square terms. And then, but it's a tricky one. Be careful with this one. So we're going to write up everything. But first thing is that this is not written in a standard form. Okay, remember, standard form needs to be written in terms of, let me go back up to remind you. Here it is. This is the standard form right here. That's the standard form. It has to be written like that. And it has to be equal to 1, not -1, not negative a number, and it has to be like that. And you have these values underneath as the denominators for y and x and stuff like that. This is the equation we got. The first thing, we have to change that to equal to 1. So that means you have to divide everything by -4. Let's divide everything by -4 every term, and then rewrite. Let's rewrite that, and then what do we get? We get x minus 1 all squared over, and I'm going to put a negative in front here and then put 4, and that's -4, doesn't really matter. And then this would be plus y plus 2 all squared is equal to 1. Okay, now if you want to, you can switch them around and put the y plus 2 squared first, but as you can see here, the denominator for y is 1, but now let's write up all the information that we need. Okay, and be aware what is happening between the conjugate axis and the transverse axis. So the center is 1, -2, okay? And we now have the vertical transverse axis. Why? Because y value here is positive, okay? And the length of this is a square root of 1 times 2. So 2 times the square root of 1, which is 2, okay? And then the horizontal, the conjugate axis is horizontal, and the value of that is 2 times the square root of 4, which is equal to 4. All right. So now, and then let's look at the asymptotes, the equation of the asymptotes. And first of all, the slope is rise over run, still rise over run. That's not going to make a difference. And remember, you have to take 1, which is, again, rise is for y, 1 over 2, because the square root of 4 is 2, okay? And then plus or minus. And then we're going to use the equation, and that would be y equals to plus or minus 1/2 times x minus k, which is 1, squared, no, plus or minus 1/2 times x minus 1, and then plus k, but k is minus 2, so it would be plus minus k. Well, I'm just going to put minus 2 in there. It would be plus minus 2, which would be minus 2. So these two are equations of the asymptotes. Okay, we can go ahead and graph what it looks like. Plot the center at 1, -2. And that's what we got, center here. Now we're going to do the vertical transverse axis. The length was 2, but you go from the center, you go up 1 and then down 1. So that would be the 2 vertices. Okay, so that's 1 in here, 1 in down there. And then once you get that, then you do the conjugate axis. Conjugate axis length is 4 in total, but you go 2 to the left and 2 to the right. From the center, 2 this way and then 2 the other way. And then remember what I said, you create this box for yourself, because that will guide you, because you do have to draw the 2 asymptotes. And this way you don't have to worry about how to graph the 2 asymptotes based on the equation. Right? This is the ugly equation. It takes a little bit of time. But what you can remember is that the line will pass through this coordinate there and that coordinate there and the center, and then another one is there and there. So there are 2 lines that go through these 2 points or 3 points. So let's graph them. So here they are, okay? And now you're just going to go and now using the values that you got using the vertices, so that point right there and then that point right there, these 2 points, you're going to use these 2 points and the asymptotes as guide to graph it asymptotically on both sections, and this would be vertical. So let's do that, and here it is. This is the graph that has a vertical transverse axis with center 1 and -2, and with all the information that we have, and we have graphed it just like that. Okay, equation of asymptote is given, and if you must find the distance to foci, you have to use the distance formula, or actually Pythagorean, and that's given by a squared plus b squared, and then add them, and then you have to take the square root of it, and that would be the distance from the center to the point foci, and then from that point on you can actually find the coordinates of the foci as well. Okay, have a fantastic day. I hope you found this useful. If you have, subscribe, like, and comment below, and let me know what else and what other topics you want me to go over. I'll be happy to do that. Until next time, be well.